Welcome to this explainer. Today, we're taking the core concepts of managing multi-agent development and turning them into a definitive, step-by-step roadmap just for you. We're going to break down the exact architecture you need to build a highly efficient agent communication protocol. So, if you've ever found yourself wondering how on earth to get multiple AI models to work together seamlessly without them completely tearing your system apart, well, you're definitely in the right place. Let's get into it.
You know, a single AI agent operating totally on its own is incredibly smart, right? It can reason, generate code, answer insanely complex questions. But what actually happens when two of these AI agents try to talk to each other? If you just throw multiple agents together into a single system without strict predefined rules, you don't magically get superintelligence. You actually just get complete chaos. They talk over each other, they misinterpret basic instructions, and they inevitably get stuck in these endless, frustrating loops.
And here's why. Human communication is incredibly forgiving. We thrive on implicit cues, shared history, body language, and, just messy context. We usually know what someone means, even if they use the wrong words. But agent communication, it is the exact opposite. It absolutely requires explicit, rigid structure and perfect clarity. Honestly, even a tiny bit of ambiguity can completely break your entire workflow.
Which brings us to our first main topic, the language of agents.
So how do we actually get these distinctly separate AI entities speaking the exact same language? At its most basic level, agent-to-agent communication is simply the foundational framework that lets these models exchange data, trigger actions, and collaborate on a unified goal. Think of it as the invisible scaffolding that turns isolated, siloed models into a highly synchronized task force, one that's capable of executing really complex, multi-step operations.
But to actually make that collaboration happen, we really need to nail down message design. Think of this like standardizing the order tickets in a super busy, high-end restaurant kitchen. If every single waiter writes down orders in their own personal shorthand, the chefs are absolutely going to make mistakes. By standardizing the architectural structure and the format of the information passed between your agents, you guarantee that the receiving agent knows exactly what to do with the data it just got. Zero guesswork required. The difference between doing this poorly and doing it well is pretty striking. On one hand, relying on an unstructured natural language prompt is just dangerous. Your receiving agent might literally decide to hallucinate a completely unrelated output just because of some weird phrasing. But on the other hand, using structured outputs like a JSON format with strictly defined key-value pairs changes everything. It gives the receiving agent perfectly organized, unmistakable data. It knows exactly where to look for the command, the parameters, and the data payload.
Moving right along to Section 2, the memory of the system.
Okay, so once your agents can speak to each other clearly using structured outputs, how do we make sure they actually remember the big picture over a long sequence of tasks? Well, this requires a shared state. A shared state is essentially the persistent collective memory of your entire system. So instead of agents playing a blind game of telephone, they reference a single centralized record of truth that tracks exactly what's been accomplished and what still needs to be done.
If you imagine your multi-agent system as this highly efficient corporate team working in a war room, the shared state is essentially the giant central whiteboard. As one agent finishes a subtask, let's say pulling a data set, it updates that whiteboard. Then, when the next agent wakes up to analyze that data, it just checks the whiteboard to see the exact current progress of the entire room. It's an incredibly effective way to keep your individual agents perfectly aligned.
And working right alongside that whiteboard is a closely related concept, context passing. While the shared state gives you the broad, big picture, context passing is the highly targeted mechanism of handing off specific, relevant background information from one agent's completed task directly to the next agent in the pipeline. It ensures that an agent waking up to do its job has all the immediate historical data it needs to understand exactly what is being asked of it in that very moment.
This actually ties beautifully into our whole teamwork metaphor. Context passing isn't just some simple data transfer. It is carefully passing the baton in a relay race. You don't just chuck the baton at the next runner. You carefully place it right in their hand while they're already moving, so they can run at full speed without dropping the objective. Good context passing gives the receiving agent the exact, precise variables and constraints it needs to execute its specific function flawlessly.
Now, let's look at Section 3, the failsafe.
Because, let's be real, we have to ask the hard question here. What actually happens if an agent drops that baton? In the real world, systems break.
You have to actively engineer your system to handle the common traps. Network timeouts happen when APIs just decide to ghost you. Malformed data structures pop up when an agent somehow generates an output that completely breaks your strict JSON rules. And, perhaps most dangerously of all, agents can get stuck in infinite logic loops, just endlessly debating each other while quietly racking up a massive API bill in the background.
So the absolute crucial point here is that a truly robust multi-agent system isn't just designed for the happy path where everything goes perfectly right. It is fundamentally engineered to anticipate, catch, and gracefully recover from those inevitable miscommunications. You've got to have retry logic, fallback mechanisms, and very hard limits on how many times agents can loop before they finally flag a human developer for help.
Which brings us to our final part, Section 4, the execution and actually building the protocol.
Let's bring all of this together into a clear architectural blueprint. Step 1. Standardize your message design by enforcing structured outputs, which gives your agents a rigid, shared language. Step 2. Establish a central, shared state so they all have a single source of truth to work from. And finally, Step 3. Wire up your context passing pathways with built-in failsafes so you can anticipate and catch those inevitable hiccups before they crash the system.
As we wrap up this explainer, I want to leave you with a thought. You now understand the profound difference between single-agent chaos and multi-agent synergy. And more importantly, you have the exact building blocks required to design a framework that orchestrates total order. So, with all that power at your fingertips, what complex problem are you going to engineer your agents to solve first? Thanks so much for joining me on this explainer, and hey, happy building.